All right, good afternoon. We are on section 5.5, multiplying fractions and multiplying mixed numbers. So when we look at the rules for multiplying fractions, we're going to see that they're much different from adding and subtracting in regards to the fact that the denominator does not have to be common. So for step 1, it says multiply the numerators together and then multiply denominators together. Simplify your answer. And when you look at this, the way to solve this is simply, again, multiplying numerators. 2 times 1 is 2. And then multiplying 3 times 4, which is 12, and reducing then by 2 to get 1/6. Now I will say that there is a shortcut to reducing, and that is always looking at my diagonals when we have a multiplication problem. So these diagonals, if they can be reduced by a common factor, then we need to do so. For example, the 2 and the 4 can be both reduced by 2. So we're going to cross that 4 out, divide it by 2, which gives us 2. 2 divided by 2 gives me 1. Therefore, 1 times 1 is 1. And 3 times 2 is 6. And you can see we get the same answer of 1/6. And instead of reducing at the beginning, we reduced at the end on the first one. And since we cross-reduced here, you can see that we reduced first before we actually multiply. You're going to find that you're going to definitely want to do the cross-reducing first, because when we get into mixed numbers, as we are later in this lesson, you're going to see that if we reduce first, we're going to end up with much smaller numbers at the end, and many times they'll already be reduced. Okay? Let's go ahead, and if you didn't copy this down, you can hit pause and do that. So let's look at this next one, and this is dealing with multiplying mixed numbers. And as I go through this, probably the best thing to do, I'm going to actually erase all of this and leave us with just the problem itself, and then I will walk you through it, which I think will make more sense than all the clutter. Okay? So, with that being said, we are going to, first of all, change all mixed numbers to improper fractions. So again, 8 times 1 is 8, plus the 7 is going to give me 15/8, times, and then 5 times, so the denominator times the whole number, that's 10. Take 10 plus the 2, which is 12, over, again, denominator stays the same. Okay, that is something that we've done plenty of already this school year, so I'm pretty certain that that will make total sense to you. Then it says cross-reduce if possible. So if it's possible, let's divide diagonally and reduce those by their common. Actually, the greatest common is best. So if we look at 8 and 12, we can divide both of those by 4. So divide 8 by 4 and you get 2. And then 12 divided by 4 and you're going to get 3. 5 and 15, you can see that you can that 5 is the greatest common factor, so we're going to divide it by 5, cross it out, and put a 1. Divide 15 by 5, cross it out, and get a 3. And you can see that I put these numbers up top and below these and make it very, very clear that those are your numbers you're working with. The more organized you are, the less likely you are to make a mistake by multiplying incorrect numbers. Now 3 times 3 is 9, and 2 times 1 is 2. Now it says multiply as you would as a fraction. That's what we just did for step 4, or 3. And then step 4 is simplifying your answer. So 9 halves, how many 2's go into 9? A total of 4, with 1 left over. Denominator stays the same. Again, we're taking 9 divided by 2 to get our 4, which is 8. Subtract, we get 1. That's where we get our 1/2. So just a quick reminder on how we ended up getting the 4 1/2. And again, all of you are becoming very comfortable in doing that mentally, so I'm pretty certain that that is not something that you need to have gone over again and again. If it is, however, that is the stuff that you need to make note of, and we'll be happy to go over with you and clarify it in class tomorrow. That's your first example. So let's look at our first one. These are obviously just plain old fractions, meaning proper fractions. So go ahead and solve according to that. Go ahead and do that. So we look at any numbers that we have diagonally to see if we can reduce, and they are not able to be reduced because they all have just a common factor of 1. So simply 1 times 3, which is 3, and 2 times 5, which is 10, and 3/10 is in simplest form, and that is it. 3/10 is your answer. Let's look at our next one. Go ahead and hit pause and solve this. So now we look to see if we can cross-reduce. 3 and 5 do not reduce. 2 and 6, both even numbers, therefore they can be divided by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. Now we have our new numbers, 1 times 5, which is 5, and 3 times 3, which is 9, and 9/5 is, in simplest form, done. Let's look at our next one. Go ahead and solve this. Now the first thing we have to do is make sure that we write them as fractions, and since this is not a fraction, we must make it one. So we have to find a number that has the same value of 4 and make it a fraction. So we're going to put this number over 1. And 4 over 1, 4 divided by 1 is equivalent to 4. So that is going to be your best number to use. There are no numbers we can cross-reduce, so 3 times 4 is 12. And 5 times 1 is 5. Now we put that in simplest form. How many 5s go into 12? 2 wholes, which is 10. 10 from 12 is 2, and 5 as my denominator. So 2 and 2/5. Okay. The key again to this is making sure we write it as a fraction. Go ahead and solve this. So 1/4 is already a fraction, so we'll write 1/4 times. This is a mixed number, therefore we have to convert it to an improper fraction. So 9 times 8 is 72, plus 4 more is 76 over 9. Now we can look to see if we can cross-reduce, and in this case we can. They are both even numbers, so let's divide them by 2, and we get 2, and divide this by 2. And you get 76 divided by 2 is going to give you 3, which is 6. Bring down the next number. How many 2's go into 16? 8. So 38 is my numerator. And so now 1 times 38, or actually let's look at this again. Is this still an even number? And it is, so we could still divide this again by 2 if you like to get 1. And divide this by 2 again, and so you take your 38 divided by 2, 1, subtract 18, and we find we get 9, so this could be 19. Now 1 times 19 is 19, and 1 times 9 is 9. If you ended up getting 38 over 18, that's okay as well. You just needed to divide by 2 again, as we did here. Or better yet, if you could see that 4 went into 76 4 times exactly, you could have divided by the greatest common factor of 4. Lots of ways you could have reduced it. So now we find out how many 9's go into 19, and there are a total of 2, which is 18. Subtract 18 from 19, and you get 1 over 9. So 2 and 1/9 is your answer to this. Let's go ahead and solve letter E. So go ahead and hit pause and solve this. So we have 5 and 1/3, so we need to change it to an improper fraction. So 15 plus 1, 16/3, times, and then 3 wholes, so 3 over 1. Now we can cross reduce if possible, and the 3 is reduced by 3. So 3 divided by 3 is 1, and 3 divided by 3 is 1. So then you get 16 times 1 is 16, and 1 times 1 is 1, equals 16 for an answer. Let's try one more. Go ahead and solve this. So again, we've got to make them improper fractions. So 6 times 1 is 6, plus 5 more is 11 over 6, times 3 times 5 is 15, plus 3 more is 18 over 5. Now we can look to cross reduce, and 6 and 18, this divides by 6 to give me 1. 18 divided by 6 gives me 3. And so now 3 times 11 is 33, and 1 times 5 is 5. Reduce that to simplest form as a mixed number. How many 5s go into 33 would be 6 to give me 30, and 30 from 33 is 3, and 5 stays the same, so 6 3/5. So again, please take note of anything that does not make sense to you. I feel pretty confident from watching what you've done in the past on this chapter that you should have pretty good understanding of it. But again, if there's something that confuses you, please feel free to ask so that we can help you further and clarify any questions you might have. Have a great evening, and we will see you tomorrow.